In this video, we are going to discuss about composite functions. When one function is followed by another function, then the resultant function is called a composite function. Most of the functions that we meet can be described as composite functions. For example, if we have a function fx is equal to 3x minus 7, so this function states that first we multiply by 3 and then subtract 7. So this is an example of a composite function. We can represent this by using a simple diagram. X multiplied by 3 gives us 3x as a result, and then subtract 7. So this is x minus 7. So you can see that x multiplied by 3 is 3x, and then if 7 is subtracted from x, we get another function which is x minus 7. We can name these function as, let's say this is g of x and this is f of x. Now gx is equal to 3x and fx is equal to x minus 7. Now if we combine both of these functions, we can write fg of x, which gives us the function 3x minus 7. Because here our first function is g of x, so which is 3x, and when we apply f on this, f states that subtract 7. So we subtract 7, which gives us our composite function fg of x. Now fg of x means that the function g acts on x first. So first the function g acts on f, and then f acts on the result. Now if we want to work out g of f of x, so it means that first f acts on x, and this is x minus 7, subtracting 7 from x, this is fx, and then on the result we apply g, or g acts on the result, which is 3 times whatever our result is, so multiplied by 3. You can see that fgx and gfx are not the same, so we can conclude that g of f of x is not equal to f of g of x. It is not multiplying g and f, it is basically applying g onto f or f onto g. Let's have a look into a couple of examples. In this example, two functions are defined. fx is equal to x minus 4 whole square minus 1, and x belongs to set of real numbers. And second function is defined as gx, which is equal to 2x plus 3 over x minus 2, and x belongs to set of real number and x is greater than 2. We have to work out the composite function fg of 4. So clearly, first of all, we will apply the function g on 4, and whatever our result is, we will apply then f onto that. So g of 4 is equal to 2 into 4, we replace x by 4, 2 into 4 plus 3 over 4 minus 2, which gives you 8 plus 3, 11, 11 over 2. This is g of 4. Now g of 4 is 11 over 2, and now we need to apply f onto that. So f of 11 over 2. F of 11 over 2 simply means that in this function f, we replace x by 11 over 2. So we will get, when we apply f onto that, we will get 11 over 2 minus 4 whole square minus 1. Solving this will give us our final answer, which is 1 over 4. In this example, we have two functions, fx is equal to 2x plus 3 and gx is equal to x square minus 1. We need to work out fg of x, gf of x, and finally f of x. In the first one, gf of x, it means that apply f on g of x. So gx is given as x square minus 1, so this is gx, and now we need to apply f on this result. And f states that whatever our result is, times it by 2 and add 3. So our result was x square minus 1. When we apply f on that, we have to multiply this result by 2 and add 3 to this. And simplifying this one, we will get 2x square plus 1 as our final answer. Similarly, in part B, we have to work out g f of x. So it means that we need to apply g onto fx. Fx is given as 2x plus 3, and now apply g onto that. When we apply g onto that, the function g is described as square your result and then subtract 1 from that. So 2x plus 3, square it and then subtract 1. And then simplify. After simplifying, you will get your final answer as 4x square plus 12x plus 8. And in part C, we have to work out f of x. So the function f applies to itself. So f is 2x plus 3, and we need to apply f again on the result. So f is 2 multiplied by the result plus 3. So therefore our result is 2x plus 3. Applying f onto that means multiply this result by 2 and add 3. And simplifying this one, we will get 4x plus 9 as our final answer. That's all for today. See you next. Take care.